See my slide?
Yes, Vivek, we can see.
Perfect. Hey all, basically, thank you for joining today. And today I'm be focusing on three different topics. One is obviously understanding Kubernetes and how we can scale applications on Kubernetes with different set of tools. I'm not using the default things which is already available primitively with the Kubernetes. So we'll be using virtual kubelet and we'll see a demo of virtual kubelets, and then obviously we will see how to use KEDA in terms of scaling your applications via event-driven approach. So given that, I just want to introduce myself. People who don't know me, I'm Vivek. I started my career with IBM as a software developer almost like 15 years back. And then obviously I enjoyed working on DevOps. So I became a solution architect at HCL. I worked there for some time on enterprise DevOps solutioning, and then I was with BlackBuck, which was a startup, managing the end-to-end DevOps, not just from building the DevOps architecture, but also the team and everything out there, and bringing in DevOps practices for BlackBuck to take it forward. And then I had my own company, and I was part of DigitalOcean, and today I'm part of Microsoft, leading the developer audience marketing initiatives. So, so basically, the most important thing is to understand what Kubernetes does. Kubernetes is more from orchestrator. It is a container orchestrator, and it basically provides an abstract layer for your workloads. How to manage your workloads. You would have a lot of infrastructure to manage, and you have a couple of workloads which is as part of as a containers, which is designed as a containers, and how do you manage it? How do you manage these infrastructure through a single interface? So that's what Kubernetes provide you. And obviously it's a declarative tool. So you are actually providing desired state, and once you provide the desired state in the form of an YAML, it takes that YAML and applies that desired state to the cluster, and then creates the complete Kubernetes cluster with required nodes, and also deploying those pods. So I'll not go deep dive into the Kubernetes architecture, but I definitely want you to understand a couple of concepts from a Kubernetes perspective. Obviously, Kubernetes cluster requires compute resource to run any kind of application, and these resources can be increased, can be decreased depending upon the application requirements. And typically, what happens is, whenever there is a traffic into your application, either you want to scale it via the via the hardware, which is your virtual boxes, which is behind the Kubernetes cluster, where you want to increase the number of virtual machines or the nodes, or you want to scale your pods, which is part of these communities, which is a container basically. I mean, scaling those pods in terms of using the container services and other things, and obviously deploying it onto the virtual boxes. So it has its own Kubernetes has its own primitive way of doing it. Like it has a horizontal pod autoscalers and other things. I'll just before I go deep dive into all those things, let me just introduce a couple of concepts how Kubernetes work. So this is a typical diagram I usually use, whenever I'm explaining the Kubernetes workflow. So this is a control plane. It has a master, it has slaves, there's a master node, and there is an API server. For that API server, there is a user who is interacting through a YAML file. You might have used kubectl. Kubectl is nothing but a client which is talking to the API server, and then there is control manager, which is actually uh, decoding that YAML file or the desired state which you have mentioned. It is actually decoding it and handing it over to scheduler. And Exet is a database which is having the complete details about the worker nodes and also the master node. I know it is basically holding the data and the state of the Kubernetes cluster itself. Scheduler uses that and then deploys the pods onto the worker nodes, which is agent nodes, which is in the diagram, but it is called as worker nodes through Cubelets. So basically, this kubelet is responsible for running the containers using the container engine, and in the form of pods. Pods is nothing but it could be a group of containers, or it could be a single container. But the basic unit of anything in Kubernetes is pod, and you can see in the diagram you can use kubelets to interact with the master node. And this is how it works. I just want to show you this diagram as well, because this gives you the flow as well. There's a YAML file through kubectl. You're just going to share the details, desired state with the master node, and master node through control manager picks it up, and scheduler takes it and deploys it using kubelets. So keep in mind there is a kubelet and there is pods which is running, and there are different kind of nodes which is there, and application is running. So here, whenever there is a lot of traffic, you see, right? I mean, whenever there is a traffic into your application, either the number of pods increases, which is called as replica sets, which is the number of pods in this diagram. You can increase it based on the replications you have mentioned in your YAML file, and also it is based on the infrastructure which you have on the worker node, or you can also increase the number of worker nodes and add it into the master node, and deploy various set of pods on the new worker node to manage the scale you are looking at. And this is already, there is an inbuilt way of doing it in Kubernetes. It is horizontal pod autoscaler, and through custom metrics, which is already there as part of the Kubernetes primitive availability, primitive tool, right? So there is already all these available. On top of this, there were two tools which was introduced. One is virtual kubelets, and the other was KEDA. And we will go through that virtual kubelet and KEDA. I'll not be doing a demo of Kubernetes, because last week itself I did a demo of Kubernetes as well. So you can go and check out those videos on our YouTube channel, which is Microsoft Reactor YouTube channel. Um, Rashmita is anyways going to paste that all link for you. So if you want to learn Kubernetes and you're a beginner, or even if you want to get into understanding of advanced Kubernetes, I think this particular link, which is aka.ms /kh 50 days. If you go through this link, you will be able to understand how exactly to build on Kubernetes, what are the core concepts, and amazing video series by Brendan Burns himself, and you can actually go through all these links. So this is a single link. With this single link, you can get access to all these content. So it's a nice content. So go through it. Let me introduce you to the virtual kubelets. So as I told you, you know, there is already built-in component to scale, and obviously those are like virtual machines or bare metal instances because Kubernetes can be used in on premises as well. And obviously there is cluster autoscaler is also available within the Kubernetes. But if you want to use if you want to scale through nodes and use the providers, and you can install and you can run the containers anywhere, like a serverless. You are not even looking at um, you're not even looking at the infrastructure. So that's when you use virtual kubelets. And this was an obviously open source project by Microsoft. And obviously a lot of people have extended it, and there is amazing set of support which has been for getting it from the CNCF as well. It became an official CNCF project as well. So what does it mean is it's making Kubernetes serverless. So what does it mean is there is a pod, there is a there is a container which you have, and you want to run that containers infinite, without any limit. Like you can keep running it in through a container instance, and then you scale to thousands of replications and scale down from that from 1,000 replications to zero. So basically, what the serverless Kubernetes does is, you are not really managing the infrastructure, and you can start within a second, and there is no wait. So if you think from scaling your cluster infrastructure, right? If there is different nodes, and if different nodes are getting if you're getting different nodes to be scaled, it's very difficult because it takes a lot of time to create a new node and add it to the master node and then use it. And obviously you're paying only for the consumptions, like how you use serverless, right? So I don't want to go into this because we discussed about how Kubernetes work. So let me go to the next slide. So this is how virtual kubelet work. So basically, you have Kubernetes API. In this diagram, if you see this API server, and this is a controller, which is the where you have the user, with the kubectl client, which is available out there, and he's interacting. And when you add virtual kubelet, right, it acts as one of the node to the Kubernetes API. So Kubernetes API thinks that there is one more node which is available out there, and through that I can go and deploy various set of pods, like how I deploy pods on different nodes using Kubelet. I can also deploy pods using virtual kubelets. So where does this virtual kubelet exist? It is just a connector. It provides a connector to any kind of infrastructure you have at the backend. For example, Azure Container Instance. You can also have an IoT setup as well. So you just it's virtual kubelet is just a binary. It's just a binary which does couple of activities, which is you know uh, by creating a pod, updating it, or probably getting status of the pod, restarting the pod, and all those things. So if you see here, right, in this diagram itself, you can see it acts as a node. It registers itself as a node. So what happens is, whenever you're running pods on these nodes, and there is a lot of traffic which is coming into these nodes, and you don't have space, or you don't have a CPU, or you don't have some infrastructure available for you to spin up a new pod, that's when you hit a threshold. When you hit a threshold, Kubernetes API decides to deploy that pod into the virtual kubelet, and thus the virtual kubelet through external connector can go and talk to the different um, different set of tools or different set of infrastructure, and obviously spin up new pods there. Ultimately it is just running a container. So that's how the virtual kubelet work. This is an example how exactly it works, right? So you have a microservice. There is a traffic which is coming in, and then there is virtual node, which is virtual kubelets, which is added as part of the as part of the node. So whenever there is a lot of traffic, there is pods getting created in Azure container instances, and it is scaling. So there is no limit. So how does it scale? It scales within seconds. So you don't really have to create a new infrastructure or a new node at which is attached to this specific um, setting, right? So it's like it is just throwing those pods into the Azure container instances and getting those pods running and getting the output as required. So that's how you can scale your application. So I mean, just to give you a use case, right? You have done a um, you're expecting a lot of users to hit your application, and everything is set, and whenever there is traffic coming in, there are different set of VMs which is attached to the master node, and those VMs are full. So how do you use the connector? So it's you just use the connector and connect it to the Azure container instance, or you can connect it to any kind of infrastructure at the backend. It could be an IoT, it could be a just the virtual boxes, set of virtual boxes as well. So you can use any of those infrastructure at the backend and um use these connectors. So if you see, the pods are getting created whenever there is a traffic in the Azure container instances, and you know that in Azure container instances there is no limit. So there basically you can scale thousands of pods there, and then you can pay for the usage, and also these pods will come down as soon as the traffic is not there, right? So that's how that's how you can actually use virtual kubelets. um, so I just want to show you a demo, but just give me a minute. Yeah, this is a demo. This is a recorded demo. Why? Because you will see, it requires a lot of network activities, and it requires a lot of um, what do you call, the different terminals, because we are going to create a lot of traffic into the application. And once the traffic is created, how it scales and how it scales down, we will see through this demo. Okay, so let me play this video so that you will. So this is a simple app which we have built. Like it's kind of a Flipkart app where you can go back and search for things, and you can see that um, whenever we have set up the virtual node, it gets added to this as a virtual node here. You can see that it is adding it as a virtual node. How does it add itself as a virtual node? So let me show you that as well. So whenever you are creating new uh, Kubernetes cluster, you need to specify the virtual node. Say for example, KEDA test, and I do. So it's here where you can enable virtual node. So whenever I do this, it actually connects to the Azure container instance directly. So it's a kind of already available on the Kubernetes cluster, Azure Kubernetes cluster, right? So but if you want to use it with different set of things, you can obviously install the virtual kubelets and see the and also provide all the right set of information, and then add your virtual node to the cluster. Okay, so that you can do it, but because I'm using Azure Kubernetes Service, I'm just by providing a checkbox, I'm able to add the virtual node here. Okay, so you can see virtual node is added with the other nodes. So this is, as this is just acting as a node. It is basically a connector to the Azure container instance. So there are a couple of pods. We are running a couple of pods, Prometheus and Grafana and online store, that online store which we just showed. And then obviously we are looking at some of the services which is running on on Kubernetes cluster. And obviously um, there are a couple of things which we are running. Okay, so this is the container, container instance, and you can see there are only three container instance as of now, three items in the container instance. And when we run the code, when we generate a lot of traffic, this particular a number of container instance grows from 3 to 50. Okay, it goes more than 50 in fact, unless and until we stop it. But uh, this is what it's going to happen now. So there are a couple of things we are using Grafana and other things to manage the whole thing. So this is the reason why doing a demo of this is a little live demo of this is a little tricky, because you need to generate a lot of traffic, a lot of things to it in a different terminals. So we are using something called as Hey. It is a Go tool, basically to generate traffic. It's a very interesting tool. In fact, you can try it out. It's available on the GitHub repo, and so it's basically to generate a lot of traffic to our online store. So we are just running that Hey tool. Um, it's available on GitHub, by the way. So just try it out. Um, so this is a GitHub link to that head tool. If you want to try that specific tool for any of these kind of test or learning purposes, uh, please go back and try and use it. It's just a load generator. Okay, so nothing else. So we have just generated traffic to the application which we have, and you can see there is traffic is being generated. Previously there were running pod were less and running instances were less. This Grafana is set up wrong. Basically it should have been with uh, 5 minutes seconds refresh or something, 5 seconds refresh or something, but it is set up in the wrong way. But anyways, we'll um, it was not applied. Okay, so we will now see how the instances are getting created. So we had seen only three container instances which were available. Now you can see, after refresh, it is 44. So this is how virtual kubelet works. You have a application. You created virtual kubelet and added it to the master node as pretending it as a node, and it is connecting to the it is basically a connector. It is connecting to the Azure container instances, and now you're generating traffic into the application, and this specific traffic is actually generating is moved these prods are getting created and containers are getting created in container instances. So you're actually not really using your making use of your infrastructure which is there right in the backend. So basically you have traffic coming in, and that traffic is generated and it's going directly into the container instance. So based on the threshold, it is not like you can actually provide a threshold. If this is the threshold, move all the pods to pods to the container instance through or virtual kubelets. So that's how you can design it, and that's how this is developed, and as soon as the the application traffic is reduced, the number of containers which is running, right, and it comes down. So, and it gradually reduces, and that's how the serverless replication, serverless kind of a thing, it provides you a serverless Kubernetes kind of a impression, right? It's not really, you're not really bothered about the infrastructure at the back end. You're not bothered about scaling, and also the availability, because everything is taken care by the provider, and it is just running through that. And we have just stopped hitting the application, and the moment we stop hitting the application, we should see some pods getting reduced, right? So that's what virtual kubelet does. And this, understand from a different perspective, right? This is from a scale perspective. You're not really scaling through an event, you are actually scaling um, through the thresholds. If there is certain number of application is getting certain number of traffic, that's how I'm scaling, and it is not based on any event. Okay, and just keep that in mind, because KEDA is also scaling, but it is basically specific to an event, specific to a trigger, and it is specific to us. You're creating a specific triggers in Kubernetes to scale that application. So keep the difference in, understand the difference. Okay. Um, so this is how you can do it. I'll not take much time in terms of running the demo. We did, now how we did was, application was there, we created a virtual node, and we generated a traffic to the application. And once we have generated the traffic to the application, the pods were created in the Azure container instances through the virtual nodes, and it did scale. Um, Scale to 50-54 container instances. Once we stop it, it goes back to zero, which is typically how a serverless works, right? So let me go back to my slide. So I want to introduce KEDA. Um, so we saw virtual kubelets, which is an open source Kubernetes cluster, and it is basically allows the Kubernetes node to be backed by the providers. It includes like serverless container platforms, right? It uses these set of things, but Kubernetes event driven autoscaling, this is also a CNCF project, and it is again open source project, obviously, because it is part of the CNCF. um, it it's basically that can be added into, it's a component, you can add it into the cluster, Kubernetes cluster. It's like an operator, you are adding it into the Kubernetes cluster, and you are scaling the containers, containers based on the workload. Okay, so how, just to give you an overview, um, KEDA is again open source tool developed by Microsoft and Red Hat, to allow any Kubernetes workload, from to benefit from the event-driven architecture model. So basically, there is an event-driven architecture model, and you want to make use of that model. That's when you use KEDA, and KEDA works by horizontally scaling Kubernetes deployments or a job. Okay, so it is not like a you know it's a horizontally scaling the deployments. So understand the deployment kind. If you're very familiar with Kubernetes, you need to understand that there is a deployment kind, or a job. It basically is scaling through that, and it is nothing new. It does not design something really new. It basically uses the Kubernetes horizontal pod autoscaler, which is already part of the Kubernetes cluster. It is built on top of that, and it also leverages the external metrics, which is there in the Kubernetes, based on the some of the criterias which is available out there. And it's basically Kafka topic, or Azure queues, or metrics and other things. Okay, so it's basically from scaling to zero or scaling to 1,000, how you can scale through a event-driven approach. So there are a couple of predefined triggers which is also available, which is also called as scalars. It's a predefined triggers which is already there, which is acting as a event source. Okay, it's basically a um, s- source for the events and metrics for auto scaling, a deployment. It can be through an adapter or other things which is already available, which is called as like Kafka, Redis, Azure queues, and other things, right? You can use those kind of adapters and scale yourself, right? And so basically, it is for each of these uh, different set of tools or metrics available there. There are different set of predefined triggers, and you have to make use of, and it is in a structured way how you can make use of that structure. Obviously, it is an operator and a custom definition, and it uses something called as scalar objects. We will see all the demos, and we will see how exactly that particular YAML file is designed and how we will plug it into the structure. And I just want to take some time in terms of talking to you in terms of how exactly it is architected, right? It does two things. KEDA does two things. One of it provides a component to activate and deactivate a deployment. So basically, it is activating and deactivating a deployment on from a scale 0 to a scale 1,000 as well, right? And it uses the Kubernetes metrics which is already available out there, and it uses it and then uh, uses the external triggers which is there, which is the scalars which is available as part of the custom controllers. You can use it in terms of running the KEDA. So there are two things which it does, right? Deployment, activating and deactivating it, and then there is a metric server which is available. Okay, so this is the flow. I'll go through the flow once. It's little confusing in terms of looking at all these things, but it becomes much easier when we see the demo and how exactly this is defined. Um, so there are three components in this in this flow, right? One is there is a scalar, connects to an external component. You basically create a container image and add the triggers and scaling rules into it. It is nothing but a simple um, scalar object um, kind. It's kind object kind, like how you define the deployments, the services, and config maps and other things. So that's similarly to that, there is a scalar object kind, and you define the triggers and scaling rules in it, and you create a pod, which is nothing but you are installing it on the Kubernetes cluster. And then you have to create a deployment where you have to tell where to which event actually needs to be scaled. So since it is scaling up specific to an event, you are looking at event scaling, right? So if there is a message which is getting added into the um, message queue, and through that you want to drive a couple of pods to consume these messages. That's what KEDA does. You are not waiting for metrics to tell you that you don't have a CPU or you don't have a memory to run a pod and other things. Basically, you want to scale this specific set of pods. So how do you do that? You already create a scalar object, add it into the Kubernetes cluster, and create a deployment. Tell that whenever there is this particular deployment is being called, um, scalar object to scale based on the rules you have set, based on the triggers you have set, and it will just scale from 0 to 1. All right. So that's how it works. Nothing different. It's all like the operators and the normal custom resources which is out there. You just install KEDA and you get all the required controllers, scalar, and metrics adapter installed. And whenever there is, you create the scalar object, add it into the cluster, and then you'll tell which event is external trigger source, which event actually does you want to scale, and then you are waiting for that thing to happen, and once it happens, it scales from either it scales in or scales out. So you can see that. And then there is obviously registration, and horizon pod autoscaler will scale up and down once at least one instance is running. So it is basically registered as a HPA to run it as a executor. So I don't want to go into a lot of theory. Basically, I want to talk to you about. Okay, I have a cluster already. This is a Kubernetes cluster I've created in Azure, Azure Kubernetes Service. So, you know, um, these are the this is the my scalar object. So here is my deployment. This is the kind deployment object model, and you know how to do this. There is API versions, and you have provided all the details. This is my image. I have just created one dummy app and use MySQL and other things to add one set of activities there. So what I'm trying to do here is I have a MySQL deployment which is running, and um, for that MySQL, I have created a scalar object you can see this name is equal to scalar object, and I have provided maximum replications it can go to is 30, and I have provided in pool interval pooling of that specific uh, a trigger, and then cooldown period of 4 seconds, and then I have provided the trigger set of things like what are the MySQL triggers and other things which is required. So basically, what I'm doing is I have my MySQL deployment which is there. I have told this is what I am looking at. If there is a state change, or if there is a one set of message which gets added, or one you are inserting something into the MySQL server, please run please run scaling scale my MySQL or dummy app, right? So that's what I'm trying to do. So this is my dummy deployment, right? So basically it's just a normal dummy deployment, and I have the image set, and it is nothing, it just does nothing. It just takes all the details and just runs it. um, and also I have an app deployment on the load balancers, and obviously it's a service kind and deployment kind is all set on top of this, and it is running. So if you're very familiar with Kubernetes, which is not the focus of this this particular session, if you're familiar with the Kubernetes, you will be able to understand what these things are and why I have defined all these things. It's basically we have MySQL app. I have told this is a scalar object. This is what I want to scale, and this is the spec I have given, how much I can scale to, and what is the cooling period and everything. And this is the trigger name, and this is how you want me to trigger, and this is the one which will scale. The dummy app is the one which will scale, right? So that is what I have mentioned here. So what we're going to do now is we're going to run we're going to add a particular record or create something in MySQL, and we will see how it starts scaling. And we can also remove the record and see how how it actually scales down, right? So this is how you can do it. There are a lot more examples. There are a lot of um, scalars available in the market, right? If you see, let me show you. um, if I open the scalar, right, there are so many scalars available. So each scalar has its own way of defining it, and you can see there is queue, and there is a different set of things which you can define. So you need to understand these YAMLs, and these understand these set of configurations. But it is easy to understand. It's pretty easy. It's like you're giving a name and scalar name available out there, and authentication details and other things. So I've also given the authentication details. If you see, um, there are um, this is the authentication details. It's basically just how do you connect to that specific service. So it's just a, these are all dummy things, don't worry. I mean, this is how you can use it. But I'll also give you the GitHub repo where you can go back and use it. um, so these are the available scalars which is there, so you can make use of all these scalars to scale your application. So this is specific to a specific external triggers. So there is a trigger, there is a object which you create called as scalar object, and you tell the deployment this is what I want to scale. And whenever there is a deployment is running, whenever there is application gets some activity or something event happens in the in the tool, um, the scalar objects kicks in, and it is obviously pulling for that in a period of time, right? So if you see, it's pulling for that every 3 seconds, and whenever there is a message is added, or a Prometheus metrics changes, or through Redis there is a some kind of data is added into the tool. It creates the trigger, and it just triggers the MySQL. So that's how the deployment works. So let me go back and show you how exactly this works. I have um, three different terminals, and let me let's let's insert a kind of a record. Before that, I just want to show you um, HPA, and then how many pods which are running. So there are a couple of pods which are running, which is part of the application. You can see this. Let me reduce. So there is MySQL scale object is running, and this is the maximum number of pods it can go through is 30, and there is no replication. It's actually zero now. Right now, it is zero. There is nothing running, and there are already running services which is available out there. Whenever I add something into the MySQL, you can actually see that it actually scales from 4 pods to n number of pods, and you can also see the number of replication starts increasing. And basically I'm running this in a loop. Okay, every 2 seconds I'm adding a record. So let me run this, and keep your eye on this particular one and this one. The moment there is a new record gets added, um, you will see there will be a change in these set of things. Please bear with my network. Um, Doing live demos are really tough. Yeah, so we inserted record, and now you see there is a replication one gets added, and you can also see now even this gets two dummy app gets created. So you will see that every 2 seconds there is new things getting added. So if you see replication two, it's already replication two. So it will keep going on. Since I'm using MySQL, it's more from record insert. So that is the reason why it's not cooling down, right? Because it's a record insert. I'm not record cannot be deleted, so I'm not designed it in such a way. So you can see that there is increase in the how it is increasing the number of pods and number of replicas of the dummy app which is there. So you can see it's live happening, it's live scaling. So this is based on an event. So Kubernetes cannot grow um, with event. Kubernetes can grow from a cluster. You can create new clusters when there is a lot of traffic into your application, and there is CPU is not available or something, through your metrics, not usual metrics. Um, or you can actually scale the pods by creating more number of replications. But again, if there is no space available, or you cannot create one more pod, extra pod into your cluster, then you will not be able to scale. So that's when virtual Cubelets and KEDA together, if you are using it together, it's very powerful, right? Because now I can scale to n number of pods, uh, and if I am using virtual Cubelets, there is no limit. You're just connecting it to the Azure container instance, and you are replicating as many number of pods you require. And once there is a application is coming down, or when the traffic is coming down, these pods will get killed. So you are only paying for the usage, not really creating more infrastructure or manage more infrastructure. It is basically managed by the cloud service provider. So if see it keeps growing, what we will do now is we will kill it. Uh, Now, because we added something, it's replicating more. What we will do now is, now I'm going to delete uh, a specific record. Once I delete, it kills all the, replicas pod, and it goes back to the state which it was. And I want to show you this as well. Um, I want to show you the workloads. And you can also access these things um, in Azure as well. It is already, see, if you see the 16 uh, dummy replicas were there, and it should reduce now. It will start terminating soon. So this is how the KEDA usually works. So this is a simple example. Obviously, if you see, I'll post a link just after this session, where you can get access to a lot of such scalars. Either it could be RabbitMQ, Apache Kafka, Redis, Azure Functions, Azure Service Bus, Prometheus. So with all these external triggers, you can obviously see that. So basically, if you see now, there is, we have reduced it to 4, and there is no replicas. So just by doing removing a record, right? So this is how it works. So let me go back. So these are the couple of resources which is available. So just go back and try out. This is KEDA and Azure functions basically. The scalar is Azure function there, and you can actually go and try it out. And then there is Azure Kubernetes Service Virtual Node demo. You can obviously understand how to build the demo there. And then there is KEDA on GitHub. You can access, and through that, there is a community samples. The sample has all set of samples which is required for this, including this demo which I did. You can obviously access it and try it out, and this is a very nice concept, so which is available. So that is what I wanted to show today. um, I want to see if there are any questions. I can take some. Any questions?
When we expand them dynamically, how do we take care of the sub-networking and the IP address allocation to them?
So which one? You're referring to virtual kubelet or
Yeah,
the?
virtual kubelet, or basically dynamically expanding the pods.
Uh-huh.
How do we take care of? Suppose you create a virtual node, or How do we assign the subnet to that? Do we need to create a separate subnet and assign it to that?
No. So basically, what happens is um, so the virtual kubelet is a connector. Okay, so it's basically a kubelet. So kubelet is a binary which is taking care of the um, which is taking care of the um, the creating a container, or and when I say container, it is pod. It's basically creating a pod, or getting the status of the pod, running the pod, making sure that pod runs, and etc. Right? It has a lot of things to do. So basically, what happens is there is no subnet or anything. There is a node which it acts as a node for the Kubernetes API. So Kubernetes API thinks that this is one more node which is having a kubelet. I just need to throw some pod out there so that it can make sure that it runs the pod and gives back me the status. So what does virtual kubelet do is through that connector, it connects to the different set of sources externally. So one of the source which I have connected is Azure Container Instance. So there is no subnet, there's nothing. You're just giving the pod. It is basically running a specific pod, nothing to do with the nothing to do with the network architecture.
Okay.
Okay.
So if that has to connect to any of the services that we want, which will be available if it is running in a subnet, so we
And
lose that feature.
no, no. You see, basically, you can create a virtual kubelet and connect. But you need to obviously provide the infrastructure. So let me show you that. Um, Let me try and just a minute. I'll just show you. Shall-
Yeah, thank you.
Sorry, 1 second. I'm just trying to find that link for you. Um, yeah, let me share the screen. Can you see this?
Yeah, yeah.
So basically, what you'll do is you provide all the details, and then just create a virtual kubelet onto the server, and you can actually see it gets added as one of the pod, one of the node which gets added there, and also obviously pod app is running. So these are the details from a endpoint, right? So basically, on any infrastructure you're running, basically you need a container engine, which is like a Docker, and then you need a virtual kubelet binary on top of that. You can actually go through the virtual kubelet website on how to deploy that virtual kubelet externally. Uh, for me, I have Azure Kubernetes service, and I can go back and just set the checkbox and install the application, install the binary, and use it onto the any of the infrastructure. But if you want to use it externally, this is how you can do it. So here, what Michel Bien is doing is not using Azure's um, checkbox, which I have used. He's creating his own um, virtual kubelet on his laptop, and he's running it.
Okay, thank you.
He asked a couple of questions in chat, but let me try to rephrase here. So it's like what and how this cost of ACI will be calculated? Because in case of AKS, it's actually the cost is based on the node size. But now we deploy this using virtual kubelet and there are n number of ports might be deployed as a part of ACI.
Correct.
So
Correct.
how the cost will be calculated for it?
So I'm not too sure about the pricing, but this is based on the number of container instances you're going to spin up, not
Hmm.
the nodes, but the container instance. That means number of pods you're going to spin up. So if you saw that, right, we scaled from 3 to 50, but
Yeah.
it is again, we're going to charge based on the number of pods you're going to spin up and obviously number of seconds it is being used. And
Okay. So it will be more costlier
when
than
compared, no,
AKS
no,
probably.
it's not. When compared to the node, um, it might not be so much. And
Okay.
again, this is only based on the traffic you're getting. For example, um, I'm just taking a guess, right? So we all do other transactions. So there is a OTP which comes to us. There are so
Yep.
many people who access for this OTP. So we need to scale that. Scale that specific thing on a specific day when there is a lot of transactions happening. But whenever there is no transaction, I don't see there will be a much transaction from 10 p.m. to 6 p.m. or 7 p.m. There's no transaction, so there is no need of that specific node or anything. So that is where these kind of use cases come into picture.
Okay. Second question is like in case of mixed architecture, when we have a Windows and Linux, both kind of node pools are there, how it will taken care as a in ACI, like it will take care to create both kind of pods, Windows
Yeah,
for Windows
yes,
and
yes, yes. You
Linux
can,
both.
yeah, yeah, yeah. It, you can create virtual kubelets with two different things. One is Linux, one is Windows.
Okay. Um,
At the end of the day, it is running.
Next,
Yeah.
yeah. And next is like instead of virtual kubelets, we also have a node auto horizontal scaler in AKS. So any guideline to choose when to choose what, like virtual kubelet versus node horizontal scaling?
See, it again depends. What I would say is if you have an application, as I told you, right, if there is an application which is going to get traffic all through the day, 24/7, there is a traffic which is there, then you know, using and using the virtual kubelets might be a little costlier. Um, Maybe nodes help you because you can create a larger nodes and use it. But when you have an applications which are which is scaling only for an hour or 2 hours or maybe 10 hours only, um, I think virtual kubelet works there. And also you can actually explore the KEDA as well, because
Okay.
which specific external triggers are supposed to be scaled, right? And
Hmm.
you go back and scale only those things.
Yep.
And that is how, I mean, that's the uh, you know that's the beauty of using virtual kubelets with KEDA, right? And
Okay.
you know what to scale, you know what specific external trigger you want to scale as part of scalars, and you have virtual kubelets which can scale to without any limit, right? So
Yep.
you are actually making sure that your application is always there and available for everyone, and it is scaling to thousands of replication.
Yep. Clear. Clear. One last question, maybe, like from my side at least, about KEDA, like how much performance intensive it is, and how much overload it will add to the like existing CPU and or a memory in terms of some percentage, if you have any experience.
Yeah, I think anyways, um, it's an operator, it's a it's going to be it will definitely consume some part of CPU and memory. I am not sure on the how much percentage, but definitely there will be a consumption since it is going to run a couple of things, and since it is going to keep pooling for things, obviously memory will be used. But um, you can see that, right? So it's not going to be I mean, not going to use up the complete like 50% or 60% uh, of your infrastructure. It might be just a pooling thing, right? And once it pools, once it knows what to scale, it just scales there. And as I told you again, using it with the virtual nodes or the virtual kubelets, I think it will be a
Yep.
minimum impact.
Thanks, Vivek. Thanks.
Any other questions? The last slide, I think the last before Twitter. Yeah, I showed that. This one, right? This is the link. This is the slide you were asking. Could you please copy paste the hyperlink for the reference? Okay. Yeah. This one. This is basically a nice demo as well of using KEDA and virtual kubelet together. So I think this will obviously a nice thing to have. Any other questions? No questions?
Yeah, nothing related to KEDA. Thank you.
Thank you all. I think Rashmita, we can pick for the day. I think we'll be obviously sharing this particular video as well on our YouTube channel. Please do take up the survey and provide us feedback so that we can come back with good sessions, more deep dive sessions. And by the way, uh, on 28th May, we are doing Azure Fundamentals for Developers Part 2. We did a Part 1, how you can deploy the applications um, in Kubernetes, in app surveys, and other particular services which we have. But the next one, which is happening on 28th, we will have deep dive sessions on Azure Functions, and also we will be using Azure DevOps, how to use Azure DevOps in this scenarios. We will touch upon the GitHub Actions and etc. in that session. And we have a wonderful, one full day event. In fact, 2 days event, May 21st and 22nd, specifically for Java developers. How to use Azure. We have good set of speakers who will be talking about microservices, how to build it on with Java, Spring Boots, and various other things with how to monitor it, etc. So I think it's a amazing set of series which is happening. So do join us at the reactor for running all these sessions as well.
Vivek, can you take one question not related to KEDA?
Yeah.
We have a situation wherein we are deploying open liberty-based applications on AKS. Do you think our virtual kubelet will be useful, wherein such applications usually have a lot of integrations with on-premise services or external third-party services, vendor integration, and so on? That was the reason that I was asking for the subnet specific question, because all our on-premises services will be all tightly coupled to networks and so on. Do you think that is a good use case for a virtual kubelet, or it is better not to use that?
So I would, if an application you're looking at a scale application, if it's an application which is used by everyone, but not really, you don't really require a scale. I think you can use the normal way of deploying it. But if you're
Okay.
looking at scaling it, I think it's a good try, right? Virtual kubelet will definitely help you drive it and manage it from a single point, right? So you have one single cluster, and through that single cluster you add n number of virtual kubelets in different locations, wherever you have, you are connecting to the master, and you can actually define in which virtual kubelet you want to deploy these set of pods and other things. There are certain rules and other things. So I think those are the things which you can definitely do.
Uh, that's
Okay.
that suddenly gives me a one more scenario, like how we take care about securities, because it
That,
could be
that's
possible that
that's where I put the link there.
oh
If you open that link, there are
yeah.
certain things which you need to provide in
Hmm.
your export. If you see that export, um, if you go to that exports, if I've just posted the link, right?
The last one, right? In
Yeah,
infra
the last one.
cloud, yeah.
Yes. So there is export, which is there. If you see that, it is using Azure, Azure client. Let me
Hmm.
also open that up. Let me. So it is using, tenant ID, client ID, secret. It is using the subscription ID. It is
No,
using.
that's clear. But like even if you have multiple pods, and because now it is a common ACI environment, and over there the pods will be coming from different namespaces, and you
No,
might
no, no.
you might have a,
It won't. In his case, it won't be a ACI. It will be his own on-premises infrastructure.
no, no, I'm
What
talking
I
in
am.
general about this virtual kubelet part. Maybe
Yes.
I think I have mixed up with his scenario,
Mm.
but in general about ACI environment, because ACI is a common environment and there all the pods coming from different namespaces, and there might be security concern that one namespace can't access the data from another namespace, and and and
Yes.
and
There
in
will be
this
no.
scenario it will be
Yeah, it is already provided within the
okay.
Azure Container Instance. The security is already provided,
Okay. Thanks,
so
thanks.
it can't access. You can't access the pods there.
Like
It's basically
ingress
an
and
extra.
outgress, because
Yeah.
it's anyways some things will coming to ingress or outgress. So if something
Yes.
will come in between, and if they can extract the ingress or outgress traffic, then yeah, might be a problem. But okay, if there is a taken care, then we'll check it.
I have one more scenario, Vivek, if you can spend 5 more minutes. We
No
have a
worries. Yeah.
scenario wherein for example, I have an Open Liberty Java application which is running in a QA cluster, and then they keep asking for additional environments wherein parallel development is going on. And I was thinking that I can go for the, say, autoscaler for the pods, where it increases the number of pods depending on the deployments. But does it also help me automatically increase the node size, wherein if there is an additional node required, for example, 10 environments requires additional 2 nodes, does it automatically add an additional node also?
Yeah. I mean, that is a different setup. That is in your while you are setting up your your cluster, you can actually provide the details, like how many node pools you want, in terms of when it is scaling, how many nodes you want to expand to.
Okay.
So that setup you can obviously provide while you are creating a new cluster, and probably you can even add that specific settings as well onto the Kubernetes class through master.
Okay. Perfect. Thank you.
Just try out that the link I gave, um, the aks.ms/kh 50 days. I'll just post that link as well in the chat. So it will help understand the um, Kubernetes, and you can talk to Burn Buns himself if you want to.
Okay.
Oops,
Thank you.
this is This is a. Just give me a minute. I'll just. Yeah. I posted the link. Okay. Any more questions? If there are no more questions, then we can break for the evening. Have a nice evening.
Yeah, have a good day.
Stay safe. I think it's a nice Friday and long weekend as well. I think for most of us.
Okay.
Thanks.
So you have
Thank
a
you.
holiday on
Thanks,
Monday.
Vivek.
Why?
Yeah. No. It's holiday on today, I believe.
Oh,
Not on
okay.
Monday.
Okay.